Hello and welcome back to another episode of Low Spec Labs. Before we get started, I would like to stop and say thank you. Thank you to everyone who has commented, thank you to everyone who has liked, and thank you to everyone who has subscribed. If you're new to the channel and you like the content I'm making, please go ahead and hit the subscribe button. Otherwise, let's get started with chapter 26 of Sander Van Voigt's RHCSA EX200, Managing Linux Containers. So, what is a container? Containers are kind of like virtual machines, and most admins treat containers as if they were slimmed down virtual machines. And that's because where a virtual machine virtualizes an entire computer, including its hardware and operating system and kernel, a container virtualizes the application and software layer. It's effectively a way for you to package all the binaries, files, and utilities you need to run a service or application and keep it jailed so that it doesn't mess with the dependencies of other services and application on your system. To understand containers, we're going to have to start with change root. What is change root? Let's go back in time. Long ago, the year was 1992. There was no way to properly lock down your files and processes. It was anarchy. But don't worry, Linux had an unsung hero, a savior, a grand wizard of the arcane arts of Linux and technology. Bill Chaswick came up with the first idea of change root jails. And he came up with this in an interesting article where he was trying to stop a hacking attempt on his freshly set up mail server. Thanks to him, the first change root jails were developed, and that led to namespaces. And that led to containers, and that led us to here today, to me talking about Podman. See how we spun that around? So, how do you actually manage Podman containers? Let's get started with learning how to install them. You can't manage containers if you don't have the container engine installed. Installing Podman is pretty straightforward. If you're already root, you can do dnf install-y container tool. And it's done. Before we proceed, you'll want to switch to a local user session. And that's because if you try to run Podman as root, you're going to give the container root access, which kind of defeats the purpose of doing containers. So go ahead and switch to your local user account and then proceed. So we've got Podman installed. How do we start our first container? Starting your first container is pretty straightforward. Let's do a podman run, and then let's type in the service we want to run. We're going to go with Nginx, which is an open source web server. And you'll notice it asks us which registry you want to pull from. You can think of image registries as app stores, and image registries store different services and applications that you can run on your server, but they're pre-baked just like the app store for your phone. So we're going to go with Docker.io because that's one of the most popular image registries. And then we'll let it run. And as you can see, it's pulling the image for Nginx. And what that basically is, it's a file that contains all the binaries and configuration files and all the other stuff we need to run a Nginx server. So this is going to take a few minutes. So how do we confirm Podman is running right? Well, we can do a podman ps. As you can see, we now have a container ID. It gives us the image, which is Nginx latest. It gives us the command it used to start it. It tells us how long ago we created it. It tells us the status, which is up for the past 12 minutes. So that's how you start a container. How do we actually go about managing it? Well, you can actually start a container in two different modes. The first is in detached mode, which is basically what we just did. The detached flag is a default option when you run Podman, but we can also run it in interactive mode, which basically means we go into that container and then we can manage the shell from within the container. Let's walk through that real quick. Some containers come built in with a shell, some do not. This Nginx container does not have a shell built in, and that makes sense for a web server. It makes it more secure. So what we have to do is download a container that does contain a shell. We can do that by doing podman run and we're going to specify we want to enter the shell by using it, and then we're going to pull a container that has a shell available, and one of the most popular ones is BusyBox. And you can see this time it pulls from the Docker registry automatically. We didn't have to choose. That's because the first time we ran podman, we chose Docker as our default, and it remembered that setting. So it looks like it started not bash shell, but the actual original shell. And we can run an ls, and as you can see, we now have a set of directories. And these directories are not on our server, they're inside of our container. So we're back to our original user session, and if we were to run a podman ps, you'll notice we've got two containers now. The first one is nginx, like we ran earlier, and the second one is BusyBox, right? And you'll notice nginx is of course running nginx, and BusyBox is running the regular shell. What if we wanted to re-enter BusyBox? Well, we can do podman attach, and then we enter the container name, which is BusyBox. So it says no container with the name BusyBox. So let's try the container ID. And as you can see, we're back in the BusyBox shell, right? If we were to hit Control P and then Control Q and run another podman ps, we've exited again. That leaves one more step. How do you actually stop a container? Once again, it's pretty straightforward. Do podman stop, and to make sure you make no mistakes, you copy this container ID again. There you go. All right, cool. And then we can confirm that the container stopped by running a podman ps. As you can see, we only have that nginx container running again. To manage containers properly, you'll also need to know how to manage container images. The first step in that is knowing where to get them. There are a bunch of different image registries, but the biggest image registry of all is Docker. How do you view what your current podman image registry is set to? If we run a podman info and then grep that info to the last 10 lines referencing registries, we can see here that we have 3 registries assigned. That's Red Hat, well, those are registry.access.redhat, registry.redhat, and the actual one we have configured, which is Docker.io. Your podman registries can be added by going to a config file. That config file, it's relative to your home user. It's in your .config containers storage.conf. But there is also another location it looks at. That location is at etc containersregistries.conf. If we were to nano into that, if we were to scroll down, you see right here that we have 3 registries registered. That's registry.access.redhat.com, registry.redhat.io, and Docker.io. These first 2 assume you have a Red Hat account and a Red Hat subscription. They're going to ask for money. The last one is free. That's the one we're going to be using. So, you know how to change your registry. How do we actually go in and search through registries for an image? That's pretty straightforward. We can do podman search, and then let's say we want to look for Caddy. That's one of my favorite servers, so let's do Caddy. Let's give that a second or two. As you can see, we get a bunch of different results for Caddy web server. So if we wanted to run one of these, we could do podman run, and then we copy the name of this container, and it would pull that exact image, which is the default Caddy server. I know it's spun up because I recognize these log messages, which are the Caddy log messages. So what we can do is Control Q, Control P. So we went ahead and we closed our Caddy server. We confirmed that by doing a podman ps-a. As you can see, the last container we have there is Caddy latest. So let's say we wanted to restart this container. How do we do that? Well, first we get the container ID. Then we do podman start, and then we enter the container ID. And now when we do a podman ps-a, you'll see this container ID is running right here. We now know how to pull containers, how to change the registries, and how to start and attach to them. How do we remove a container and container image? Removing a podman container is pretty straightforward. We do podman rm, and then we enter the container ID of our container, which is right here. If we were to then run a podman ps-a, you'll notice that we have nothing listed. Most container images you pull are going to be from open source repos like docker.io. If it's open source, that means somebody else wrote the code, and you should probably inspect it. Even if there's not malicious code inside of that container, it might be configured wrong. So being able to figure out how the container is put together is going to be very important for you. So how do you actually inspect a podman container? So we can do a quick podman inspect. Let's do podman ps to get our container ID first. We pull this container ID, then we do podman inspect. And as you can see, it gives us this output, which gives us basically I believe this is a YAML file that contains all the different configuration settings for this container, right? So it gives us stuff like the entry point, the state, the paths and images it's using. It gives us stuff like the image digest, which is basically a hash of the image for us to verify that we actually downloaded the right one. It gives us lots of information here. Podman inspect is just one way to inspect our podman images. There's another command we can use to inspect podman images, and that is scipio. But before we can use scipio, we're going to need an image to inspect with scipio. So let's find one. So off screen, I did a quick podman search limit to nginx. And what that did was print out a list of different images in different repositories we have access to. So now that we have our image name, we can go ahead and run a scipio inspect. So let's do scipio inspect. Then we want to point this to Docker, almost like we're pointing it to a website, and then we enter the name of the Docker image. I see what I did wrong there. I have to put 2 slashes after the protocol. And we wait a second, and there you go. You see it gives us the output of what would be its Docker file or podman file, depending on which one you're using. So you know how to start, stop, and remove containers. And we also know how to inspect container images. How do you build your own container image? There are 2 ways to create a container image. The first is to create a container file that somewhat automatically helps you build your container image. And the second way is to manually pull the image down from a repo, configure it, and then recompile a new image. Let's go through both those methods. Let's start with creating our container file. First, we have to make a directory. So we're going to make dir container store. Then we have to cd into that directory. So we do cd container store. After that, we have to make a container file. So how do we do that? First, we do nano container with a capital C, file with a lowercase f. From there, we then type in our container file. So the very first line is from, and then we paste the image we want to pull. After that, we type in run. Right, so we're pulling an Ubuntu image, and generally when you pull an Ubuntu image, the first thing you want to do is update. So we do apt-get update, then we do another run, and we do apt-get upgrade. After that, we then do run, and we can do an apt-get install nmap, because that's the utility we're putting inside of this container. After that, we're going to run a command with nmap. So we do command, we then do 2 brackets, and then we pass through the command flags as we would for nmap. So we do comma, nmap, space, another set of quotes. We pass through the flags, comma, space, and then we put in the network we want to nmap. This field right here will change based on the command you want to run after the container starts. And there we go. So now it's going to pull this Docker image, update it, upgrade it, install the tool we want, and then immediately run the command afterwards. So let's try that. Let's do podman build -t, and we're going to tag this Ubuntu nmap 1.0, and then we have to point it to the container file we want to use. So you use the dot to point it to the container file. As you can see, it just pulled the image, it's running an update, and as you can see, now it's installing nmap, and we're done. Now, when we run a podman image list right here, you can see we have an image tagged Ubuntu latest right here. So now that we know how to build a container image using container files, how do we build a container image manually? First, we start by pulling down our container image. To do that, we use podman pull. It's straightforward. We do podman pull Ubuntu latest. And there we go, it's downloading. Then we run our podman images. We can do a quick podman run -it. We give it a name of Ubuntu latest, and then we point it to the image, which is Ubuntu latest. And we're now inside of that Ubuntu container. You can see because it says root at, and then it gives us a serial number versus where before we had my username at localhost. Now that we are inside of the container, we simply set it up like we would any other server. So here's what we do. We run a quick apt-get update -y. Then we do an apt-get upgrade -y. Then we can go ahead and install the packages we want. So we do apt-get install -y nginx. And then we also want to do default JRE because nginx needs JRE to run. And there we go. Cool. So we now have nginx installed. From there, we hit Control P to pause the container, and then Control Q to quit. And after that, we then have to commit the container. I went ahead and ran a podman ps-a to list our containers. How do we commit it? Well, first we'll need our container name, which we get by running podman ps-a. Then we do podman commit, and then we paste our container name, and we give it a second for it to do its thing. Then we can confirm the container got created by running a podman image list. As you can see, we now have an additional container here without a tag and without a repository. To tag the container image, we do podman tag. So a quick podman tag, and then we want to give an ID. So let's grab our image ID, and then we're going to call this Ubuntu dev. Now let's do a podman image list. And you'll notice this image right here now has a tag called Ubuntu dev, and it's the latest version. Now, how do we create a container from that image? Straightforward once more. We do podman create, we give it -- name, Ubuntu dev, and then we give it the path to this image. There we go. Now we do podman ps-a. You'll see we now have Ubuntu dev right here, and it is using the image we made right here. And that image is made from the base Docker image we pulled down from the Docker repo. What is podman exec? Podman exec is a way to send commands from your host into your container image and have them executed. Let's go ahead and practice with podman exec. Got our shell open up here. Let's do podman ps-a to list our containers images. We want to start Ubuntu latest. So to start a shutdown container, you do podman start, then we do podman ps-a one more time. You can see the container is up. Now we can do podman exec. We put in the container name. Now we can do a podman exec -it, and then we put in the container name, and then we put in the command we want to execute, which in our case is bin bash. And there we go. We've just entered the container, and we've entered the shell. Now that we're in there, we can run it and do normal stuff, ls, printwd. It's still a Linux file system, right? What if we wanted to exit the container? We could do that, restart it, right? Let's say we wanted to do ls/etc, right? And it just listed everything inside of that container's etc folder. What if we wanted to do podman exec Ubuntu latest ls/, you see it lists everything inside of that container. We can verify it's inside a container by doing something like home, and as you can see, the only user in that folder is Ubuntu. Rootless podman containers, which is what we're running, do not come with an IP address. The reason for that is complicated. Basically, giving your container an IP address kind of defeats the purpose of hosting containers. Instead, depending on which version of Podman you're using, either rooted or not rooted, you're going to have to use port mapping. Port mapping is basically doing NAT translation from the container to the host. In order to have the web server reach out from the container to the internet, we're going to have to map a port on the host and on the container, and then that is what is going to allow the container to connect to external network devices. A practical example is probably going to work best for me to explain what exactly is going on. So let's go ahead and start with a quick podman run. We can do podman run -- name nginx port, do -d -p, and then we define the port we want nginx to run on the host side, so we'll do 8080. Then we define the port we're forwarding on the container side, which is 80, and notice how we use the colon to separate those two. And then we type in the name of the container we want to download. And we'll go ahead and let that run. Now if we were to do a podman ps, you'll see we have nginx running, and you'll notice the output of this is a little bit different than the output of this. For instance, we have a port, it says anything to port 8080, 80 TCP, nginx port. So this is basically saying any IP address within the container goes out to port 8080 on our host. Then we have to add that port to our firewall. To do that, we do firewall cmd -- add port equals 8080/TCP -- permanent. We have to run it as admin. There we go. Then we have to do a firewall cmd -- reload. And there we go. So how do we verify this port is now open? Well, it's pretty straightforward. We can do a curl localhost 8080. And as you can see, it gives us some code, some HTML text from our Nginx server. And as you can see, it says go to Nginx for Nginx configuration settings, yada yada. What are environment variables? In the context of containers, an environment variable is a variable you set. An environment variable is a variable that you set the value of outside of the container, and it configures settings inside of the container. A lot of containers will need environment variables for them to even start. So let's go ahead and walk through starting a container with environment variables. MariaDB is a database application that is often deployed with websites. It expects a bunch of different environment variables like your database username and password. Let's see what happens when we try to run MariaDB without that information. So if we were to do podman run docker.io/library/MariaDB latest, you'll notice that it failed. And actually it's nice enough to give us an error message right here. It says you need to specify one of MariaDB password, MariaDB hash, MariaDB allow empty root password, and MariaDB random root password. So basically, to get this to run, we need to pass it a username and password and our environment variables. Let's go ahead and do that. To pass through environment variables, you need to do the -e flag. So we're going to do podman run -e, and then we're going to do mysql user equals bob -e mysql password equals password -e mysql database equals mydb, and then we're going to set the root password of another -e, and we're going to do mysql root password equals password. Then we're going to forward the port. So we're forwarding port 3306 to port 3306 from the host, from the host to the container. And then we're going to point it to the Docker registry, and let's see if it starts. And there we go. It gave us that output. Now let's do a podman ps-a, and you'll see the first attempt at running this failed right here, and that's what gave us these error messages up here. But the second attempt at running it actually started, and that's because we passed through the appropriate environment variables. Container storage is ephemeral. What does that mean? That basically means if you were to make changes inside of your container and shut it down, all those changes would disappear unless you turned it into an image. And if you were to open that image and make changes inside of that image, those changes would also disappear. So how do we make storage persistent across containers? Let's find out together. To make storage persistent across containers, we use bind mounts. What that basically does is it takes a local folder or directory and then it shares that folder or directory to the container. Then any changes made inside of the container will be kept on our host system as well. Then if we were to shut down that container, the changes would persist. There are some gotchas you need to know when you're trying to bind mount file systems to containers. The first is that the folder, file, or directory that you're trying to bind to container must be owned and writable by the user running that container. The second is that the appropriate SE Linux context must be applied to that folder. If the user is the owner of that folder and it has write permissions, the proper SE Linux context should be applied automatically. So how do we pass a bind mount into a container? We use the -v flag, of course. We would start our container like normal using podman run, and then we would do -v, and then we point it to the file system on our host, and then we point it to the file system inside the container. First, we start by making our file. Let's do an ls and see what directory we're in, and then let's make a directory, and we're going to call this nginx store. And you'll see we now have a folder called nginx store. Then let's do an ls-al to check the permissions on that folder, and as you can see, it's owned by my user. After that, we start the container like normal, but this time we're going to pass the -v flag. So we do podman run -s name nginx, and then we do detached mode because we don't want to drop into the shell. Then we use -v to pass through the file system. Then we do // for our local directory, nginx store : and then we point it to the file system inside the container we want to mount. So we do /root, and then of course we point it to Docker and we tell it to pull the latest nginx version. Now if we do a podman ps-a, you'll notice it is running. Now let's do this, and let's do touch and // nginx store test. Then let's echo hello world into // nginx store test. Now let's enter that container and see if we can list the file system. So let's do podman exec -it, so it's interactive, nginx, and then we want to open up the bash shell. So we type in bin bash, and we're now in the bash shell of our container. Now that folder should be mounted to root. Let's see if we can list inside of root and see our file. Permission denied. So what happened there? Remember how I said SE Linux labels must be correct? I think that's what's going on here. So let's exit the container, clear, and then let's list the container again. Let's go ahead and remove it, and we're going to rerun the previous command we ran, but we're going to add an extra option to it, and that should automatically relabel our SE Linux context. So let's type in nginx to remove the container. Let's go back through our command history, and then what you want to do is run podman run name, give it your container name. We don't want it to be interactive. We want to pass through a file system, and then what we're going to do is add one more :z. Now if we were to do a podman attach, and let's do ls/root, and as you can see, we have that file called text inside of there, and we can now access it. So So let's do cat slash root test. As you can see, it says hello world. And that's it. That is how you bind mount your file system to keep your data persistent across containers. The cool thing is if we were to go back, so let's do a control P, control Q to close our container. And we were to echo, let's do hello world again into our bind mount folder. And of course we want to append this, so we're going to do now. Let's start the container one more time. Let's do podman start nginx. Well, let's do a podman ps first. Okay, so it's still running, so we should just be able to reattach it. Now let's do a cat slash root hello world. And as you can see, we now have that additional hello world again. So basically all the changes we make inside of that container is going to be transferred outside and vice versa. We could do something like echo hello world again and send that to root test. Now if we were to exit this container and we were to do cat slash test, you'll see the change got copied between both the container and the host. So containers are very powerful and they're a great way to set up a service, but a service isn't very good if it doesn't automatically start. So how do we automatically start containers as system services? Let's walk through that process. It's pretty straightforward. First, your user has to be able to start systemctl processes. One option we could use is to pass the -user flag. So if we were to do systemctl -user, now we could run systemctl under the user context of whatever user we're running our containers as. The problem is that if we were to restart our server, until we logged in as our user, the service would not start. So how do we get around that? The first thing you want to do is do sudo loginctl enable linger and then point it to your user that you want to enable. What that does is basically tell systemctl to automatically start all of the user specific systemctl files. Otherwise, when we reboot the server, until we log in as our user, our services we set up under this user will not start. So the next step is to turn our container into a service. How do we do that? Well, you can create a unit file manually, but your chances of making a mistake are pretty high. Or you can go ahead and do podman generate systemd --name. You point it to your container name and then do -- files. And there we go. Now the next step is to enable that unit file. Then we go ahead and we enable that unit file. So to do that, we do systemctl --user enable, and then we point it to our local unit file. And as you can see, it started up. Now if we were to do systemctl --user status container, you'll see we now have a service under the user context, and that's our container file. And that is it for chapter 26. And actually that's it for this book. We're done. We've gone through 26 chapters. I don't have anywhere near enough fingers. But imagine I had 26 more of these little digits right here. Right? And with that, we have completed Sander Van Voigt's RHCSA exam book. I know there's still a little bit here, but this is mostly just practice questions and definitions at the end of this book. What does that mean? Well, that means I have to take some time and rest. I've spent the past 7 months learning how to manage containers, and my brain is tired. So I'll see you guys around. I have one more video I promised to make for somebody, so I might get started on that in a couple more days. And that's it. After this, we're going to start some Ansible stuff, and then I have my eyes on learning Azure. My new job has me wanting to learn that in order to be proficient in my role, so that is where my attention is going to be going.